When people think of pollution, examples that come to mind might include oil spills, overflowing landfills, or receding glaciers. But the unseen, unheard danger posed by anthropogenic space debris may well be the greatest of all.
I'm Andrew Swackhamer, and as a research assistant at the Space and Sustainability Initiative at CU Boulder, I study sustainability, safety, and security-based norms of behavior as they relate to the problem of orbital debris in near-Earth space. The conversation surrounding orbital debris stretches back to the 1970s, when Donald Kessler first proposed the idea of a self-propagating debris field in near-Earth space. In the following decades, various efforts were made by the international community to implement mitigation guidelines. However, by and large, there has been a total and complete abdication of responsibility regarding the space environment by nearly all spacefaring nations. The data tells us that the progress made thus far has not been sufficient to stem the growth of the debris population. Space is incredibly valuable for the everyday person and society writ large. Between GPS, remote sensing, weather, and communications, space enables a wide variety of everyday applications that many of us often take for granted. Perhaps one of the most relevant space-based technologies when it comes to social responsibility is environmental monitoring. Much of the data that we have on climate change originates from satellites, whether it be forecasting extreme weather events such as hurricanes or flash floods, analyzing current levels of emissions and deforestation, or predicting rising sea levels and their impacts on coastal populations. In recent years, it has become clear that the commercial space industry is poised to take the reins from governments when it comes to their presence in space. But now that we are aware of the risk that space debris poses, it is the responsibility of these industry actors to ensure that their operating practices do not contribute to the uncontrolled growth of the existing debris and improve upon existing guidelines and best practices. My research has put me at the center of this conversation, as I am working with a diverse set of commercial satellite operators and other key stakeholders to define and establish a set of orbital rules of the road for their everyday space operations. Specifically, we are working to identify operational standards that will simplify and streamline the resolution of conjunction scenarios involving two or more active satellites with collision avoidance capabilities. This will serve as a concrete example of how industry can come together to ensure that their actions do not impose an undue social cost on the world, and will encourage other spacefaring actors to adopt a similar approach. This renewed sense of urgency surrounding space is incredibly exciting to myself and my peers, but we must remember our moral obligation to the hundreds of millions, if not billions of people that rely on these capabilities to survive and to thrive. As the next generation of space leaders, we must ensure that the future of space is conducted in a safe, secure, and sustainable manner.